and just having fun coding. I work for a government agency called the AGRC. It is a terrible acronym for the Automated Geographic Reference Center. We basically just deal with spatial data for the state of Utah, and there's actually some initiative to change our name, so we'll see what happens there. But this is us down here, bunch of bald white guys. I'm part of a development group that builds custom web applications. We've kind of evolved from using Dojo to React. We've done some Angular stuff. So I'm happy to talk about any of those things if you want to reach out. We build applications kind of like this that help businesses kind of figure out where they can relocate to Salt Lake. So, you can get real estate stuff here and economic development type things and access to recreation and transportation. We work with other state agencies like DNR to build web applications that they use to manage restoration projects. So in this project here, there was a fire and they planted some seeds and put down some herbicide to restore that. And then we also do kind of like workflow type stuff. So if you're not familiar with unclaimed property, go to this mycash.utah.gov and type in your name or your friends' names and see if they owe you any money. Because they actually, I never heard about it, and they owed my wife like $100. So we got a check just the other day. But we analyzed all their data and helped them kind of figure out where they should focus their outreach to get all these millions of dollars back to people who probably don't realize that they're owed money. We work with voting stuff to make sure voters are in the right precinct so they get the correct ballots. We also purchase and distribute aerial imagery. So like base maps here. So you could add this to one of your web maps. We've got a few of them. This is the hybrid one. It's got aerial imagery flown with a plane. We've got some vector ones that show data really well on top of them. We've got terrain, topo, which is the USGS scan maps. And then we've got a color IR, which shows like vegetation. So you can do some fun stuff with that. Over here, we've got one of the React components for finding an address. I think if I put an east in there and we do Salt Lake City, it'll zoom you there. So you can see the vegetation around there, the aerial imagery. You can find your house, look at your car in the street. Let's see what else. We have this thing called the SGID, which stands for the State Geographic Information Database that started back in the 70s. And it's evolved over the years, but it's basically just a core set of data aggregated or provided from other state agencies. And we do some work to create statewide data sets for that, for like parcels and roads and things. We also run a GPS network, which has a whole bunch of GPS stations across the state that are linked together, and they correct anomalies from some satellites. So if you're building bridges or doing stuff like that, you connect to this network, and if you start on either side, you'll meet in the middle. And then we also do some coordination stuff, some events, Maps in the Hill. You can come up and show off some projects. We have a annual statewide conference called UGIC, and then there's other user groups that you can get involved with that we link to out on our website. So I'm going to talk about the evolution of a Python script. I wrote a blog post in 2017, and now I'm just going to turn it into a presentation. And I chose this because Python is kind of it's a common language for spatial analysis and spatial stuff, and it's kind of an approachable language, like the syntax and whatnot, for non-technical people. And in my field, it's typically geographers and cartographers, and they don't have a programming background. And so I think Python is pretty approachable for them. And as the field has evolved, programming has become kind of a required thing for daily tasks, like automating stuff and bulk processing of things. And Python's really good at that. And so one of the vendors that enables us to do some really cool spatial stuff is Esri, and their documentation has they have a lot of documentation. It's pretty good, but they show a lot of like snippets of code. And I think that promotes like copy paste programming. And you all know that that's not like the best thing in the world. So I wrote this to kind of help folks in my office up their Python game. And so some resources that I can show you that we're going to use today are our website. So let me close a couple of these tabs here. Did anybody check if they're owed money yet? So this is our agency website. It's built with Jekyll and hosted on Netlify. So if you're into that, I'm open to talk about that as well. Here you can find like access to the latest stuff, spatial. You can find, you can browse our data that's organized by these ISO categories. You can download aerial imagery. We've got developer resources and blog posts and a little status page about how our stuff is doing. Then we've got all of our stuff is open source. So we've got a couple of GitHub organizations. So everything that we do is in here. We've got 135 repositories in /AGRC and /AGRC widgets. So like that address zooming thing that I did is called Dartboard, and you could just npm install that and add it to your application if you wanted to, if you're doing some front end stuff. What else? We've got the Ajrc Web Api. This is a .NET ASP Web API. So if you're into C# stuff, I'm super happy to talk about this kind of thing as well. The next version of this is a .NET 5 sort of microservice Kubernetes thing. So if on any of that stuff is interesting to you, I'm happy to chat about it on Twitter or wherever. But this is the endpoint that we used for that geocoding widget to figure out where on the map that address was. And then we've got things to do that, to invert that, reverse geocoding route. We got milepost stuff, and then we've got a search endpoint to expose the SGID through the web. And then to sign up for that, I should say, you can just go to register. It takes you to developer.mapserve.utah.gov, and you can just sign up for an account. And we just ask that you make API keys so we can see who's using the stuff and track analytics and all that. Otherwise, it's free to use, no limits. We've got another offering of the SGID, which is a Cloud SQL PostGIS database running in the Google Cloud. And we give public access to that. It's got a whole bunch of layers in there. We show you a couple ways to connect. Here is an application called dbeaver, which is free, open source. And the OpenSGID, I got a connection here. And we got all those ISO categories for organization. And I'm just doing a query for fire perimeters. And dbeaver can show those geometries in the map, which is pretty cool. Let's see, we've got Open Data. Open Data is built as a vendor solution. It's an Ember app, I think, with a Rails backend. Again, it's got all the ISO categories for finding data, and we publish all of our SGID layers to this thing called ArcGIS Online, which is a platform as a service, I think. And it allows you to upload data, and then it creates services from those. And so open data is a way to organize those services and discover them. So we're going to be using all those things today. And so let's just jump into some code here, talk about Python scripting. The first example I'm going to show you is just pretty much the way I typically see most Python scripts start. You have a need, you want to automate it, and you just create a file and you start importing things and installing things, and it's great. It works. It's simple. It's fast. You know, you're not writing documentation because you're the only one that cares how it works. And I'll run this here, and that's kind of what it does. So here I just have an API key that I'm getting as an environment variable. I'm passing an address to the web API, and then I'm pulling out the coordinates. As you can see, whoa, that's not good. What happened? Timeout. Let's run that again. So the coordinates geocoded to these coordinate numbers here. And now that one query is being too slow, I have a 5-second read timeout. So let's just scroll up. So the web API and our spatial data is stored in a coordinate system called UTM-NAT83. And we do that because when you have a round Earth and you need to flatten it, that projection creates the least amount of distortion for data in Utah. So you get the most accurate area calculations for polygons and length calculations for lines. And this is in meters here. A lot of popular open source tools will use Web Mercator or latitude longitude, and you can just pass in the ID for that, and our API can return that for you. But we're going to use the default because that's what our data is stored in for the search API as well. So I just made another HTTP request to the search API for county boundaries. I pulled out the name, found out that address is in Salt Lake. I looked at land ownership, and it's owned by a private entity. I looked at some parcel data, and the building there was built in 2015. It's worth a lot of money. It's pretty big, and it's got 4 floors. This last request, if I run that again and just kind of up this timeout, I'm not sure why that's taken so long. It'll tell you that the elevation of that is around, 4,300 feet. And so if this does what you need to do, if this was the thing you had to do and had to do it multiple times, this is great. This script runs. It's simple. It's good for prototyping. This style is good for kind of like disposable functionality, I like to call it. But it has some issues, right? Like we hard-coded the address. So if you wanted to look at another area, you'd have to edit the source code. You know, the environment variable would have to be set if you were going to run this on a different machine. And so hard-coded values are typically, you know, looked again, like not something you want to try and keep in your code. And that's things like file paths and API keys and service accounts and things like that, because that really hinders your ability to share stuff, you know. So if you get like see my data, you know, that just doesn't really transfer that well, and you have to document it to make it work right and edit source code. That's just not great. So, and then another issue is if I deactivate my my virtual environment and I try and run that query again, my Python modules aren't installed. And so that hinders shareability. You have to kind of document somewhere else what your external libraries are, and that's just sort of pain in the butt. And so if I'll turn that back on, we can move to kind of the next sort of upgrade. And for this example, we're going to use the OpenSJD Postgres database. So we have to add a import for a Postgres database driver. And we're also going to import sys, which gives us access to argv, which basically is an array of items that are passed to the command line after the Python token. And so then we can kind of pull those values out using just array syntax. And we can assign our API key to value 1 and the street from value 2 and the zone from value 3. So if I run that, we can see that I just ran Python and the file name. I passed in an API key and a street and a zone. And then you can see the parameters. The first one is the file name. Then we got the API key, street, and zone. We got the coordinates. And then I'm using Postgres, like I said, to turn the geocoded point that I got, or the geocoded address, the coordinates, into a point. I'm changing the spatial reference, or I'm setting the spatial reference to 26,912, which is the UTM. And then I'm doing a near search on the shape to that point with liquor stores. And then I just order it by the distance, so I get the closest one, and I only care about the closest one. So we can find out that Red Rock Brewery is the closest place to get a beer. Rose Park's the closest place to go golfing. I'm doing a query on recreation golf courses. Ski resorts is Snowbird, and if I wanted to go for a hike, we've got Ensign Peak would be the closest one. And so you can see we kind of made this script a little bit more generic, right? We can pass in any API key, any address, really. So if you give this to your buddy, they can run it and they can look at their house. They can, have their own API key, track analytics and stuff. We kind of got rid of quite a few hard-coded values with the street and the zone. And you don't have to edit the script to successfully run it, right? To change it and stuff. So, but it also has some issues. If I run just the command, just the file, you don't know the order. There's nothing telling you what parameters are there or that it even accepts parameters, unless you write documentation and all that kind of stuff. So while this is an upgrade, you still need good documentation to make people successful using it. And we still have that dependency issue where people don't know what dependencies to install. And so we can kind of we can do better, right? So the next thing I'm going to show is what I kind of differentiate is a console application. And so to do that, we're going to add this docopt module. And docopt is a command line interface description language. It takes your doc string and converts it into a command line interface parser. It has like a pretty simple syntax. Anything after the file name is a subcommand, and then anything with greater than, less than is a positional argument. And then you can do single or double dash flags. And square brackets denote optional. And so in this case, you can either do any of these optional flags, or you can pass all of them. If you used parentheses, those are like required type things. But DocOp, they've got good documentation for that. It's implemented in many languages. They even have it implemented in JavaScript, so you can run it in the browser, which is pretty cool. And so we can document our script, and just with this import here, and down at the bottom somewhere, you just pass your doc string to this module. Then you basically get a console application, what I call a console application. And so if I run this, and even without the help flag, it tells me what I need to do to make it work, what it expects. And if I do pass help, it gives me the full documentation, whatever I write in that doc string. So you can document everything. And so following that syntax that it provides, I can write at the terminal something like, give me the utilities at this address and use this key. And so if I run that, I get the coordinates, and I get that there's fiber internet available from CenturyLink and Beehive. This yellow text is the parsed arguments from DocOpt. So optional flags are Booleans, and you can see API key was true. So API key has a value of the API key. The positional arguments have the text, and then my subcommands that I just used to kind of make it read better also are Booleans. And to do this, I used open data. So I was querying ArcGIS Online feature services. And so I should just show that real quick. So I chose utility data, and let's just look at electrical services. And so this is the open data website. It shows you some metadata and whatnot about the data you're looking at and the geometries and stuff. You can also get a quick overview of the attributes. You can peek into the data, and so I just requested the provider, and over here you can download the data if you wanted to. There's a GeoService link URL, and if I go to that, I kind of get like a, what do you want to call it? Kind of like a Swagger doc or an open API type of thing where you can try out the API. And there's a ton of options here, and you can choose JSON, HTML, GeoJSON, or protobuf as your output type. But in our case, I just passed an input geometry and with the intersect relationship, and I asked for the provider as an outfield. And so you can see that here. I kind of made an ArcGIS Online query method that just kind of passes all the things that I need for that to happen. And there's the coordinates from the geocode, and again with the spatial reference thing, and then we get the fiber providers. And so if I pass the all flag, I can figure out who all of my utility providers will be if I was going to move into a house at the address that I provided. So we've got Dominion, Rocky Mountain Power, and Salt Lake Water. So this is pretty cool. I think that's pretty neat. It makes your API kind of self-documenting. You can sort of maybe be a little bit more lazy on documentation, because all you need to tell people to do is run it and then look at what it outputs, and then you can go on and just do what you need to do. And then if you put things in incorrectly, it doesn't do a great job at telling you what you did wrong, but it just says, hey, this is the syntax, you didn't do it right. So try again. But then we still have the dependency issue because we add another dependency that doesn't come with Python base library. And but we can fix that too. So the way that I like to fix that, and what we've kind of done as an agency, is we've kind of just created this template in GitHub, this AGRC Python. It sort of follows the happy path to get some really nice features. For instance, we've got code coverage, right? So 100% code coverage, and it's got continuous integration builds with Travis CI. It's got linting set up with PyLint. We've got PyTest set up with a test that'll run, and you don't have to kind of figure out how to make it run. You can just run PyTest and it'll work. And so the next evolution of our scripting is kind of this. I'm sorry, my dog's really excited about this. Is kind of to end up sort of in this area. We have a setup.py, which allows us to create an installable module that we can then share easily. And so I'll just go through how that looks. So I just cloned that repository into this project here, and instead of just having one file, we've organized it into a source folder with the project module name. We've got tests, and then just kind of like some other dot files to make your editor and all the other things kind of light up. Inside of the module, we add an init.py file, which is empty, but that is like a fancy file for Python that makes this folder a module. So you execute it as a module instead of as a Python file. I can talk more about that if that's confusing, but so then everything sort of comes together with this setup.py, and you can give it a name. For this example, I just chose SGID. You can version it, give it a license, a description, all your stuff that the Python package index will use, which is similar to NuGet or NPM or whatever you're familiar with as far as package managers go. This just uses pip and PyPy. And then we can put all our requirements here. So we know that everything kind of works well together, and when this is installed, everything will be there that is required. And then we have this extra requires that you use to do development. So if you want to work on this project rather than just use this project, then you need all these things to kind of make everything else light up. And the last piece is this entry point. So when I use SGID in my terminal, it kind of maps it into this SGID folder, this main file, and then this main method. So when I call SGID, this method gets executed. And again, we're using docopt to parse our doc string. And in this example, I just sort of made a pretty tool. So with the syntax, what is that? And you can pass an X or a Y, or you can pass an API key and a street and a zone, or you don't need to pass that at all because it's all optional. And then the only required bits are from a table and attributes, and then an option to do this. For this, again, I'm going to use the OpenSGID. So we need the Postgres. And to use this package, you would, if it was in the Python package, just pip in whatever name we publish it as. If you're a developer, and the console application, you can pip install, and then you just need to install from the directory that has the setup.py in it. And I'm passing the editable flag. You don't need to do that. That just kind of links it so that any changes you make to this file will just automatically propagate without having to reinstall. So if you run that, it reads your setup.py and it installs all your stuff, and you can see I've got SGID installed. And so now on my terminal, I have the SGID thing. I can run that from anywhere. I don't have to access the Python files for that module. I can run it in any folder, and it'll just work. And so the syntax for that is shown. I've got some examples here, so you don't have to watch me try and type. But in this example, I'm just going to take some coordinates, and I'm going to request the name from the municipal boundary layer that's in the OpenSGID. And you can see the doc.op parsed stuff, and then it's in Salt Lake City. And so kind of with doc.op, you can just sort of, where'd that go? You can just sort of branch on those options and provide the functionality that you need. Here's another example using street and zone with an API key. Again, just city names, and that address is in Mill Creek. And then one more example without using any input location, just querying the database. I'm just going to query municipal boundaries where the name starts with an M. And so you can see these are all the cities in Utah that start with an M. And the PostGIS database is super powerful. Like, you can do all kinds of spatial stuff. You don't need any proprietary software to use that. Same thing with the Web API and the Open Data ArcGIS Online feature services. We're trying to kind of remove the need for proprietary software to access GIS and spatial data. But you can do distance and buffers and queries. And so, I mean, if you've got address data in a database or any sort of location-based stuff, you can hook it up to these services and enhance your data. And so I guess to wrap up a little bit, evolve your Python scripts, right? Like, make them easier to use and better, because I didn't say it up here, but that disposable script that you ran or you created, it's likely to be running in production in less than a week. Like, we've had that happen more often than not. So if you do it right, you'll be in a better spot. And like I said, if you've got address data or anything that could be spatial, enhance your business with that spatial data. You know, visualize your customers and see sort of what trends and information you can extract from that. Go sign up for our web API, get an API key, start doing stuff with that. You know, query our database, look at some things just for your own interest if you're curious. You know, we've got a lot of data in there. If you're worried about more earthquakes, you can see how far away your house is from some active faults and stuff. We've got a lot of geoscience data in there. And the SGID just isn't that one 1970s CD-ROM database anymore. It's all these facets, and you don't need proprietary software to use that. And so each of those facets does have strengths and weaknesses. And so some considerations, if you do want to end up using some of these services, is if you're going to do geocoding, any scale job our geocoder can do. Just don't try and DDoS it too hard because we don't do rate limiting and stuff yet. And we don't have any restrictions on the results. If you're already using Google or somebody for geocode results and you're storing that data, then you're violating the terms of service. So use our stuff instead. The search endpoint on the Web API is great for things that are only web accessible, kind of like browser-based applications and stuff. But if you're going to, try and enhance an entire database worth of stuff, using the Web API to do that will probably take a long time because of network latency and stuff. So in that case, you'd want to connect to the OpenSGID and do some database queries and aggregate queries. That'll be much faster. So use the OpenSGID Postgres database for that. If you have Esri software, you can connect to that and visualize and do spatial analysis. If you don't own that software because it is expensive, QGIS is an open source alternative that's free and can connect and really integrates well with PostGIS. And then if you want to just do some like quick one-off sort of web mapping type things, use that ArcGIS Online. Use those feature services. That the platform as a service that Esri offers caches most of the queries at their edge, and so it's very fast for displaying things like that. And then that query endpoint that I showed you for those feature service can do some really fancy things. And so if our search endpoint can't, it's kind of limited, you can switch over to those feature services and do some pretty cool queries and pretty neat analysis. So with that, I'll open that up to any discussion or questions or. And I'll also stop presenting.
So do you ever use the SOMPY library?
SOMPY?
Yeah.
No, I haven't.
It's kind of like the OpenStreetMap.
Oh.
It's where it's got a lot of the addresses across the United States, and I think it's got most addresses in Utah.
Yeah, we met with the OpenStreetMap. I don't know, they have some sort of governance level. We met with one of the ambassadors, I'll call it, for Utah, and we tried to work with them to get our street data in there. But the way that OpenStreetMap works is they don't accept bulk imports. So we would have to do it one at a time. And because, people have done some, are we good? I'm frozen. Shoot.
I can still see you.
I can hear you.
All right, my machine's frozen, so, or just my browser at least. But so with the community input, they don't want to overwrite that stuff with our data and kind of squash and piss off the users that have done that. So we haven't been able to get our data in there, and they started with some really old data. So our geocoding in Utah should be a little bit more accurate, but that's pretty cool because all
right, now he's frozen.
Yeah.
What other questions while we're waiting to come back? Anybody else have some more, or just wait for that? How many of you guys have done mapping stuff in your software?
I have.
Right.
Yeah, it's pretty much my main job.
Yeah, well, thanks,
There you are.
Chrome.
Oh, there you are again, Steve. You disappeared for about a minute.
Yeah, sorry about that. I guess the takeaway is we've been trying to get our data into OpenStreetMap. It's been hard to do, but our geocoding results should be a little bit better.
So do you have the ability to download like the whole data set of all the streets that you have, or do you have to do it through the API?
No, yeah. So our website on gis.utah.gov and on the open data, we have 4 or 5 different outputs that you can download every data set that we host. Shapefile, file geodatabase, CSV, and then do whatever you need to do with it.
Cool. This is great.
So, Steve, you mostly showed us Python stuff. Do you guys have any JavaScript specific projects, or just using the existing kits that are out there from Esri or whoever?
So we do use the Esri JavaScript API quite heavily, and then we've got those React components that we've started to put together. Just because pretty much every web application that we build more or less has like the same 4 or 5 things in it always. So like that base map selector and that Atlas website is a React component that pretty much every application we have uses. Then we've got that geocoding widget and a little search thing that you can hook up to a feature service. But mainly, I mean, we've done some leaflet projects, but more often than not, we're using the Esri JavaScript API. I can show you pretty much anything in there, but I'm not quite sure what you'd want to see.
I have something I could ask.
Sure.
That sort of at the very end of what you were talking about, when you were sending those XY coordinates to the API to get the nearest features, was that being done on the Esri REST or ArcGIS Online server, or was that being done in your PostGIS setup?
That was a PostGIS. That was a database query.
Okay, so what do you serve out through the Esri's ArcGIS Online endpoints versus?
So we try and keep everything the same, right? So we try and keep our PostGIS database catalog the same as our offering in ArcGIS Online and what's available through the web API. So that's why I kind of put those considerations in at the end, because you can get the data from 3 different places, the same data from 3 different places.
Okay, so if you were to input a point and ask for like the 10 closest schools, that's being done on your PostGIS?
I think PostGIS makes it easy. It has the best functionality for doing that. Because if you were to do it through a feature service, it's not very efficient. You would have to like buffer your point into a polygon and keep expanding that until you got at least 10 points. Whereas in PostGIS, you just use that little, like less than hyphen greater than, and then it does that for you like in a very efficient manner. So doing nearest searches, I would choose to use PostGIS if that was an option, just because it is it'll be the fastest and the least amount of developer work. I should mention that the next API that I'm currently working on, the C# thing with all that other stuff, I'm working on a GraphQL implementation, but the holdup is, and I don't know how many C# developers we have here, but have you ever heard of Hot Chocolate for GraphQL? I'm working with those guys to add spatial types to it. So you'd be able to do nearest searches through the API with our PostGIS backend. They had to rewrite their entire filtering implementation to handle spatial.
Yeah,
Go ahead.
Oh, that'd be really useful. I looked at some GraphQL stuff that the guy was trying to build in C#, and the tooling just wasn't there for some of it yet. But I can see where that would be really convenient.
Yeah, so GraphQL or Hot Chocolate version 11 is pretty close to being released, and it's pretty cool from what I've seen. I don't know a ton about GraphQL. I just sort of applied for an innovation grant and was awarded it, and I've spent all the money trying to add spatial to GraphQL without really knowing much about GraphQL itself. And I've only gotten the input and output types added to the library. The filtering and the querying and stuff is coming next. So you will be able to do that nearest with the next version of our API without too much friction.
Nice.
I was wondering, so you worked on the Utah Economic Development Map project? Was that one that you specifically worked with?
That was more so my colleague Scott Davis, but I have helped on it.
I was just curious what your team looks like what kind of roles on there. Do you have analysts? Do you have user experience designers?
So I was talking with Brian earlier. We have like 12 or 13 bald white guys in our office, in our whole agency. So a lot of people kind of do a lot of things. For that economic development application, we did use a UX designer and a UI designer from our parent agency, and they made a whole bunch of mock-ups for us, and then we just turned like some Adobe mock-ups into I think that might still be a Dojo application actually, so Dojo widgets and whatnot. And then we have a project manager, and we typically do everything in the open. So we'll create some project boards in GitHub and do all our issues there. Since we're a government agency, we kind of have to do scope of works and statements of works and whatever. So like we kind of have to estimate and bill up front. So that sort of takes away from a little bit of kind of like an agile approach, whereas we kind of have to understand most things up front. And then if the project needs a back end, I'll typically work on that. And if the project, and then whoever has time, or if we want to work together, depending on deadlines and stuff, a couple of us will work on the front end together. So I mainly do the back end work, and we've got a couple of people who can work on front end stuff.
Cool.
And we do have a QA. Our parent company agency has been ramping up on QA QC. So there's one lady, and you just got to get in her queue, and she'll test all your stuff for you. But Mainly, we just write unit tests and kind of do all that ourselves and push that onto our customer and our project manager.
Cool. You have cartographers as well?
Yep. We've got 3 cartographers, one of which was around in the olden days when you would scribe and do all that stuff I don't understand. And then we've got 2 more digital cartographers. One is pretty talented, and that's kind of his main focus. And the other one, we just hired not too long ago. He has a planning background, and he can sling some Python code, and he's got a pretty good artistic eye for cartography. A little shout out to Zach Beck. He won an award at the Esri conference for one of the best maps that they submitted. That's pretty cool. It was like an elevation map with the highest peaks and stuff. But yeah, mostly in our office, we're split up into kind of a data team, a development team, and then a cadastre team, which deals with the GPS network and parcels and the PLS stuff, which is all those like things that people go geo tagging or whatever it's called, geo whatever, searching for those little boxes and stuff. There's like monument markers. If you ever seen those brass markers in the ground, we kind of have a digital map of those. And then the data team, they work on all the data aggregation from the counties and other local government and roads and things. And because I forgot to mention that our street data and address point data is used when you call 911. So when you call 911, they either ping like the cell tower or whatever landline address is associated and get your coordinate and then intersect a dispatch center. So they route your call to that dispatch center, and that uses GIS. And then once you're on the phone call, there's a thing called a Psap, which I don't know what it stands for, but they are basically like, okay, where are you? And if you say, I'm like, I can see this sign on the highway, or I'm at milepost 10 on I-15, then their software can use GIS and our data to actually figure out where that is to dispatch officers or ambulances or whatever. So that's kind of how we're organized.
It's awesome. Is the 911 stuff on the open data, or is that more sensitive?
Well, the data behind it is, yes. It goes through some third-party software. I'm not too involved with it, but we have a guy who's just dedicated to that, and he helps with the Psaps. There's a company called Spillman, I think, that uses that, and Fat Pot is another one. And then AT&T, I believe, works with those companies to bring everything together and to keep it up and working. And there's like a whole new next generation 911 thing that's slowly evolving, and I think GIS plays a bigger role in that as well. But I don't know too much about that. It scares me a little bit, actually, to know that, like, if we screw something up or if the data's wrong, somebody could get hurt.
Yeah, it's heavy.
Yeah, it's nice. Like when Chrome crashes, nobody dies, but yeah.
So I had a question. Do you have like, how you have like what you're nearest to? So something like all the webcams that are close, or all the cameras that are out there, or anything like that where you can do like tracking?
Yeah. So Esri has a software that you can purchase called Geoevent, which I think I can't remember what they're using. They're using an Apache software underneath it, but it basically is a real-time tracking, like a real-time like server type of thing. So DNR has a couple of projects using that, where they have collars on animals and they track where these herds of animals and birds and stuff go throughout the state. And that's one of the reasons why on I-80 they built that elk bridge above I-80, that millions of dollar thing, because they could see that all the animals are trying to cross I-80. That WRI project that I talked about, the progress of building those fences along I-80, the deer fences, and all the culverts that go underneath that they can cross under the highway. And then we also built a wildlife collision application that UDOT contractors go and pick up carcasses and inventory certain things about the health of the carcass. But yeah, so Esri definitely has solutions for real-time tracking of objects and temporal data. And then they also you can do some fancy things like geofencing, which I think we'll start to see more of in the future. If you walk by a coffee shop, you'll get a push notification for a coupon or something because they know you're out front. There's a lot of applications for it. I have not been too involved other than setting up the infrastructure for them to use. The pelican tracking one or seagull tracking one got a lot of news, I think, coverage. And the wildlife tracker one actually outgrew the Esri software, and it now sits in BigQuery in GCP using Psap and a couple other really cool cloud technologies. Because BigQuery has spatial data access, and we'll probably be pushing all of our spatial data to BigQuery at some point in the near future. And that'll open up a whole lot of possibilities for people who have data that could be spatially enabled to do really fast intersection and data enhancement. And we wouldn't have to foot the bill for that. We would just supply the data and they would pay for the compute. So that'll be another facet of the SGID that you'll probably see in the next year or so.
So another question. I know I've gone to some of those ArcGIS meetups, but there's like hundreds of people at them. Do they have like smaller groups that are doing that kind of stuff?
Well, there's the Salt Lake City Slug, Salt Lake user group that does GIS related things, and sometimes people present on the JavaScript stuff. But I think the audience is typically more analysts doing stuff. I go to the Esri developer conference in Palm Springs, and there's about 3,000 to 5,000 people there, and it's a week-long conference. I don't really know of anything smaller locally. They tried to do some outreach and they tried to start like a user group, but it just didn't really catch on. They did like one or two things over at that sports bar by Broovies.
Okay, thanks.
Oh yeah, GeoBeers, that's the OpenStreetMap folks, I think.
I've gone to that a couple of times.
Yeah, so you've met Martine?
Yeah.
Yeah, yep.
I go to the Map on the Hill almost every year too. I like that.
Oh,
stuff.
do you?
Yeah.
And where you work?
I work at a place called Penicity.
Okay.
I used to do a lot of municipal. I I'd make a lot of maps for different municipalities across the country.
Yeah, so you've probably met most of our staff then.
Yeah.
Maybe we've even run into each other. That's
Could
cool.
have.
That's cool. That's great that you participate. It's a really neat event, I think.
It is. It's exciting, the stuff that's going on, technology.
Thanks, Brian. There's one for Maps on the Hill as well, if anybody's interested. And we have a Map Utah Twitter account that we tweet out some events, and we just had our UGIC virtual conference last week, I think. I need to update the website. It probably still has the old stuff on
it. I've got a question I've wondered about. So you guys work with data from tons of different local entities or state departments, whatever. How do you manage integrating that and reconciling differences and syncing it with all the different people who consume your services and provide data?
All right. Python does a lot of it. We have a ton of ETL scripts for certain data sets, depending on who's providing it. Typically, we'll get the same data schema and whatnot from the same county or agency. And then Zach Beck, the cartographer, he manages the process for address points. And I'm pretty sure his process for getting new data is he truncates and loads that county's addresses. For streets, we have quite a bit more complicated process. We've got some custom tools built with C# and Arc Objects, which is kind of the foundational SDK for all the Esri desktop products. And it's like a 12-step process with manual intervention on every difference. So we do, the roads update happens on like a monthly schedule, but we do a different county every month, or maybe a couple of counties every month. And the main, there's like the big 5 or something, like the super urban ones, we do more often than the rural ones because there's more changes and development happening. But we get that data and we ETL it into a certain schema. And then we use some Esri tools to do some change detection. And then based on that change detection output, we have some more custom tools to filter that out even more. And then we bring it into desktop GIS, and we built some tools that integrate into the ArcGIS software to go through each change and compare. And like a human has to do this, like click next, see the change, the map zooms to it, you see if it's a geometry change or an attribute change, and then they decide. It's kind of like a terrible merge conflict, because we make updates to the data and we try and push those updates back to the county, but sometimes the county is slow to incorporate that change, or they disagree with that change, which doesn't happen as often, but it does happen. For instance, like this school, we just published some new schools data sets, and they gave the driveway to the school their own address. They just made it up. It's not addressed anywhere else, but the school is using that. And so, we need to rectify those things for when people put an address on their website or something. It's not a valid address. And so we have to manage our set of updates versus their updates and differentiate between those. So it's we have one guy who does that part-time, and he's our database administrator. And so that's pretty complicated process. But then We also have another Python tool that we call Forklift, and Forklift is kind of like a really fancy Windows task scheduler, or kind of like a cron job sort of thing. And it runs all of these palettes to keep with the forklift theme. And we do some change detection in our database to see if data has changed. And then Forklift pushes that data to all of the different parts of the SJD. So all of our spatial data is stored in an internal SQL Server database, but then Forklift on a daily basis pushes out the changes to ArcGIS Online, PostGIS, the Cloud SQL database, and to our GIS server. So everything that's being used for the mapping applications has local data on that machine, so that the queries and stuff are fast and we're not using database connections and stuff. So we have a custom Python tool that runs a two-phase process to figure out what's changed and to ETL stuff, and then to actually ship what's changed to the places that need it. We have a diagram of that, but I'm afraid to show it because it's pretty scary.
Yeah, that sounds complex. I've been on the other end of some of that stuff, so I was kind of curious because I've seen it come and go, and I realized it was a big mess.
Yeah, it used to be pretty simple, and we would just schedule a Python task to run the Windows scheduler, but then things started to overlap and take too long, and they would break because something started before the other thing finished, and so we saw the need to kind of serialize that. And that's where Forklift came from.
So do you have anything like demographic type data that's associated with like latitude and longitude more than, sorry, my dog's barking. Any more than like what you'd get on like American Community Survey, where it's more down to like the house level or anything like that?
So I'm not super familiar with our demographic data, but we don't produce any demographic data ourselves. We do serve spatial demographic data provided by either the census or the organization that you just mentioned. But I want to say that we don't go any further than like the census track. So
okay,
it'll be interesting to see all the new census stuff that comes out of this most recent one. Yeah. I don't really know how long the turnaround time is on that.
Usually like a year.
Is it really?
Mm-hmm.
Yeah, but if you went to our open data and just clicked on demographics, you'd see all the census stuff that we have.
Okay.
I can't believe how much stuff is on there. I'm going through it right now. It's really cool.
Yeah, there's way too much stuff. We even removed a bunch of stuff. We slimmed it down like the last year or so. We've got a big metadata project ongoing now with a technical writer, where we're trying to improve all the metadata about the data sets. So when you click on one, you understand how it was created, how much you can trust it, when it was last updated, and all that kind of stuff. What all the fields mean. We're trying to remove all of the coded value domains. I don't know if that makes sense, but like with databases, a lot of the times people would have a lookup table where you have like one is purple, and that was back in the days where you were worried about the cost of a byte, and so now we're trying to get rid of that so that you don't have that that friction to understand what that is, especially in a world where we're publishing like single tables and we don't have that extra lookup table to do the join. So instead, we're just trying to put the value in there as it would be if it was looked up. But otherwise, that data would be contained in metadata, and metadata is like documentation for source code. You know, it's kind of a last afterthought, and sometimes it just doesn't get done. So. It's a big effort, but it'll be really great once we do it. We kind of have like framework layers, which are the most important data sets, like the stuff that supports 911 and voting and you know, like municipal boundaries and county boundaries. So we focus on those first, and then we'll try and hit the other 200 and 300 layers.
I think GIS is one of the only areas I've worked in that has metadata baked in as an expectation and as a first-class citizen, really, so you can track where stuff came from. I've kind of missed that in other fields I've worked in now.
Yeah, it's like data science has that as well, because your results need to be reproducible, right? And people are going to argue with you on your methodology and your bias to, with the result that you come up with. So you have to document all the steps that you took to come up with your result. And that's like the only other place where I see, that sort of information. But it's great. I love it, and Python notebooks are another kind of way that you can kind of document your process as you go. I'm gonna put myself in the drawing.
Oh, you're too late.
Oh, I already lost.
I drew one earlier. Sorry.
Oh, bummer. Who won?
John did.
Nice. What was the number?
It's 54. He almost got it.
Oh, okay.
By the way, thanks.
Yeah, no problem.
Yeah, thanks, Steve, for taking time to put that together and walk us through some stuff.
Yeah, and like I said, I'm happy to talk about any of those things that I work on, and Twitter's a good way to reach out, and I hang out in some Slack channels and stuff too. So. Love to hear what you're working on, and if it could be improved by using some of our data and services.
All right, well, if there's no more questions, I'm going to go ahead and quit recording, and you guys can hang around and chat for a bit if you want, but otherwise, thanks everyone for coming.